Assalamualaikum warahmatullahi wabarakatuh. Dear committee and participants, my name Zahidan Abdul Mana. Today I'm going to present my research, which is about modeling vegetation index changes in Taiwan from 2000 to 2020. The contents that I'm going to present today, which are introduction, materials and method, finding and discussion, conclusion and future recommendation. Let's begin with introduction. Normalized different vegetation index (NDVI) is a plant health index of greenness on land that can be used to analyze the density of vegetation on the ground. The vegetation is one significant to the energy balances on regional and global scales. Vegetation changes not only interrupt carbon dioxide and water cycle but also influence energy balance of the Earth's surface and affect land surface temperature changes. The increasing deforestation and human population affects climate change, especially reduction of greenness. Most of the change of NDVI has considered large area of mainland countries. However, there are few studies on NDVI changes from an urban heat island, of which Taiwan is one example. The expansion of population and deforestation in Taiwan has influenced vegetation changes. Therefore, this study aimed to investigate NDVI seasonal patterns and trends and to estimate NDVI increase per decade by subregion and region in Taiwan from 2000 to 2020. Material and method for the study area were used to study in the whole Taiwan island. For the Taiwan Islands, we divide the area into four regions, which are northern, central, eastern, and southern. In each region, we divide into 9 subregions. For the whole country, we have 36 subregions. For the latitude and longitude of each subregion, we get from Google Earth programs. For the data source, we download data from the Moody's Vegetation Index website. For the product that we use is Vegetation Index, Terra 16 days, 250 meter. The data was downloaded from 2000 to 2020, which are 20 years. There are approximately 20 observations in each year. For the total observation over 20 years is 441 observations. The NDVI define value from -1 to 1. The values from 0.6 to 1 it indicate a forest. The value from 0.2 to 0.4 represent grassland and shrubland, while the value from 0 to 0.1 specifies soil, concrete, rock, snow, and barren land. For the negative value, it indicates as the water. For the statistical analysis, we use cubic spline method to model NDVI seasonal patterns, and then we adjust seasonal pattern by calculate that we take the original value and subtract the predicted pattern and adding the mean value to certify that average NDVI over 20 years period are unchanged. And then we use the linear model to find the trend of the NDVI. Furthermore, to detect the temporal autocorrelation, we use the ARIMA model. And the trend of the NDVI from ARIMA model of each subregion were illustrated in time series plot. Then the NDVI increase by region were visualized on the Taiwan map to visualize the NDVI changes over 20 years. In order to eliminate spatial correlation and to get the average increase of the NDVI by subregion, we use multivariate regression. Lastly, we use forest plot to summarize the confidential interval of the increase of NDVI per decade. For the finding and discussion, the first result was seasonal pattern. From this figure, the y-axis is indicate NDVI value and the x-axis indicate the day of the year. The result shows that there was a steady increase of NDVI in March of subregion 1, 2, 3, 4, and 7. For the subregion 3 and 6 had 2 peaks of NDVI. For the seasonal pattern for other regions, show broadly similar pattern for each year. For the NDVI trend, this figure shows the NDVI trend. For the y-axis, it shows the NDVI value. For the x-axis, show the year from 2000 to 2020. The result is indicate that in subregion 8, in region 1 has the highest mean NDVI, which was above 0.8. On the other hand, for subregion 2 had the lowest mean NDVI, which was below 0.4. And the NDVI show increasing trend in all subregions except subregion 15, 22, 23, and 27. For this figure is also it indicated increased value per decade and the p values. Actually, this value we use to indicate the increase and decrease in subregion. For the mean increase and z value from the last panel, we use to indicate the increase of each region. The NDVI increase in subregion and region as shown in this figure. This figure shows that the NDVI in all regions had increasing trend, except in the eastern Taiwan with stable trend. We can notice here we got the red, which means that it's increased trend, and for the eastern Taiwan is the stable trend. For the confidential interval plot, it's used to indicate the increase per decade. From this forest plot, it shows NDVI had increased 0.01 per decade. For the discussion, vegetation index had increased by 0.01 per decade. This study supports the finding from Tisa and Young 2016 that there was a slightly increase in NDVI from 1982 to 2012 in Taiwan. Moreover, the finding from the current study is consistent with the result from the global NDVI trend in the previous studies. They indicate that NDVI had increased in several regions of the globe. For example, from the Western Europe, Southern United States, Amazonia, and also in the China also is indicate the increase of the NDVI. For the conclusion and future recommendation, the study demonstrates an effective approach to time series data for modeling spatial and temporal change NDVI. The study found that NDVI in Taiwan have increased in the last 2 decades. One of the main industry and significant factor in Taiwan is agriculture. The growing farming, for instance, rice, coconut, cocoa, chocolate, coffee, fruit, vegetable, tea, and flower had caused increase in vegetation index. The climate and spatial changes are terrible threat to ecosystem. Therefore, this is a signal to the Taiwan policymaker to campaign against global warming. The causes of the increasing trend in this factor need to be investigated in further studies. Thank you for your attention. Wassalam. Is there any question?